You're listening to the N2K Space Network.
Today is June 19th, 2023. It's Juneteenth here in the U.S. I'm Maria Varmazes, and this is a special edition of T-Minus. 158 teams from around the world were selected to compete in the 2023 Spaceport America Cup. Over 120 will make it to the competition in New Mexico, which runs from June 20th to 24th. T-Minus Space will be covering all the action at the world's largest student rocket competition. We wanted to know what it takes to be a team in the Spaceport America Cup and spoke to a rocketeer from London that's traveling to the U.S. to compete for the first time.
My name is Adrien Coutant. I am the co-leader of our competition team in UCL Rocket. So UCL Rocket here encompasses sort of 3 divisions now. One is the main competition team, which I'm a part of, and who participates at Spaceport America coming up. And then we have 2 other divisions, one for first-year students who build a rocket for the National Rocketry Championship here in the UK, and another team doing some experimental work. We call it the Rocket Experimental Division, RED. I'm a mechanical engineering undergraduate, finishing up my 3rd year. One day last year, I was at a networking event for the Mechanical Engineering Society here at UCL. I ran into our leader at the time, and she said, "Hey, are you into aerodynamics?" So I said, "Yeah." She said, "Do you want to join the rocket team?" And I said, "There's a rocket team? I didn't know that even existed." See, our team only was founded last year, and just on a whim, I joined the team, got to meet the other students. They were all super welcoming, and we got started pretty much right away working on our first big rocket, which launched last June. Now I'm co-leading the team, which again, I'd never expected to happen, but I'm really happy about it. So I remember when I joined last year, everybody was talking about the Spaceport America Cup, and it sounded like, this huge thing, how big of an achievement it is to even just participate at this competition. So when we came second at our competition last year, which was our first proper competition, it kind of gave us a good base to stand on with the university who are funding our projects. So we said, okay, let's take on Spaceport America. Let's go for it. So we applied for the 10,000 K-foot category. We're happy to say we got accepted, and we've been working really hard this year on a new design. We chose this year to focus a lot more on sort of the basics of high-power rocketry design. Our motto this year has been repeatability, reliability, and redundancy. So that's sort of been our ethos in designing this rocket. We really want to create a good foundation for the future years to come, to allow for more ambitious projects. We got maybe a liquid engine in the works. For this year, our main goal is, because we know how big of an achievement it is already, just to be able to come to the US, participate in this competition, be amongst the big leagues. So after we applied for the competition, at the time we didn't even have a team. We filled out the application form and got accepted, and then we got to work on 2 things. One was outreach. So we weren't sure about getting sponsorship from the university this year. So we were working really hard on producing a nice brochure and contacting companies to try and get some financial support. And then also on conducting interviews for some new students to join the team. Took us about a month, and then finally we had a team, and then we got to work on our design. We spent quite a lot of time on the early design stage. Our leader, Shurem, who's really just kind of a pioneer when it comes to design, his approach has really been for us to forget all of the assumptions that people make when it comes to designing high-powered rockets, and just, go really down to first principles and question everything. Why is it that we design sections in this way? Why is it that the rocket needs to separate twice or only once, depending on if you're using a tender descender, for example, with your parachutes or not. And we really got to question everything. That way it gave the whole team a proper basic understanding of how every single component of the rocket works. And actually that's turned out really well, because they explained to us that when we get to the competition, there's going to be some very thorough safety checks going on, and they're going to be asking us lots of questions, the whole team, and everybody has to be able to answer those and be really knowledgeable about the rocket. So this is kind of an iterative process of going back and forth between design and also selecting manufacturing methods and materials. And once we kind of had a good enough understanding, then we got into using CAD. That's one thing that we like to not do, is get into CAD too early. That's one thing we learned from last year, is that we ended up having to go back and make lots of changes, because when you actually get to building and manufacturing things, you realize that certain components can't be designed in this way because, they won't fit together, or the 3D printer just can't print that way. And after having made lots of mistakes and lots of fixes, and again, this iterative design process, then we got to testing our rocket. So the ground testing, which is testing ejection system that we use for recovery, which is a black powder system that we went up to test at the East Anglia Rocketry Society, that we've made really good friends with. I think that's actually been very key also in achieving the design that we have this year, is getting help from rocketry hobbyists, such as our mentor, Ben Jarvis, and other universities as well. We've been in contact with Leeds, as well as Strathclyde. And everybody's just so friendly and so helpful. Everybody in the team kind of has their own different goals or personal growth that they're working on with this challenge. But I think as a team, we just really want to show the department, all of us doing these projects, extracurricular projects, we really can achieve some pretty great things. And I think another big thing will be creating relationships. As I mentioned, we have some good ones here in the UK, but now we're going to be having access to all these other teams. I think we're going to be spending a lot of time on the conference day, going to see what other teams have done and trying to learn a little bit from them. And also take the time to discuss with the team, where do we see our team going from here? Now that we've kind of built a nice, simple, but well-designed rocket that we're happy with, how can we start to innovate, sort of challenge the things that have already been done and make some more exciting projects, maybe a liquid engine. I'm definitely, so excited about aerospace now. I've been following, launches a bit more with SpaceX and Starship. I'm definitely much more interested in that now. There's just something about knowing that, the work that you do every day eventually leads to, and this is why the liquid engine is so exciting, is to eventually this explosion of fire that, can launch a huge mass into the air. I don't know, there's no feeling like it.
That's it for T- for June 19th, 2023. We'll be bringing you more from the Spaceport America Cup throughout the week. We'd love to know what you think of our podcast. You can email us at space@n2k.com or submit the survey in our show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening.